Welcome back, folks. In today's class, I'll talk about the circular motion. Circular motion. Previously, we talked about the linear motion. Linear motion. So, what happened in the linear motion? That the object was moving in the to and fro direction. So, it was moving either in the east direction or in the west direction, or the object was moving in the vertical direction, that's north and the south. So this was the example of when there was a gravitational force. This is the example we've learned when the object was moving on a road in the forward or in the opposite direction. So that kind of a motion is called the linear motion. Now what if the object is moving in a circular direction like this? That's a circular direction. So I wanted to find, first of all, let's say the object started from here, and I wanted to find the velocity with which the object covered this displacement. So this displacement which the object has covered in a circular direction, if I apply the simple basic math rules, so this is the circumference of the circle. So the circumference of the circle will be equal to 2 pi r. So how are we going to find it? If I cut this, this is the distance. If I cut this circle, it will roll up like this, and this is the displacement. And this displacement can be figured out by using the mathematical formula in a circular format. So this was the circle, and this circumference of the circle is equal to 2 pi r. And then I wanted to find the velocity formula, the same old basic formula which we've learned, that is the change in displacement delta d divided by change in time delta t. And change in displacement in this case is equal to uh, this is equal to 2 pi r and divided by time. That will be the velocity in this case. Now let's say one of the important things we need to learn in this case is that velocity will keep on changing its direction at every moment. So this if the object is moving in this direction, this is the velocity direction, this is the velocity direction, this is the velocity direction here, this is the velocity direction here. Now this begs me a question. Let's say there is an object which is moving in a circular direction with a constant velocity of 5 meters per second, let's say. Now I wanted to find out what is the net force acting onto this object which is moving in the circular direction with 5 meters per second. Now because the velocity is constant, so most of the time we are tempted to write down that, okay, the velocity is constant, so there is no net acceleration is zero, and then F net will be equal to mass times acceleration. So mass times zero, this value will come out to be, net force will come out to be zero. But that's not actually true in this case, because although the velocity is constant, but it keeps on changing the direction. So what I'm trying to say is the magnitude is constant, but the direction is not the same throughout. So here if the object is moving in the counterclockwise direction, here it is here the velocity direction is in the west direction, here it is in the south direction. When the object reaches here, it is in the east direction, and the object reaches here, it is in the north direction. So at every moment the velocity is changing. Even here somewhere in the, you can say it is somewhere in the southeast direction, yeah. And then this you can call it as somewhere in the northeast direction. So at every moment the velocity is changing. So even if the velocity given uh, to you is constant in a circular direction, you still cannot take it as the constant. You cannot still call the force as zero, because the velocity direction is changing although the magnitude is same. So the formula to find out the force F net in a circular direction is mv square upon r. That's the formula you're going to use. And net force is also called as centripetal force in a circular direction. Centripetal force is the net force, and this is denoted by fc. So whatever function f net used to play in the linear direction, f net used to play in the linear direction, same role will be played by Fc now. So this is basically a net force, which is equal to mv square upon r. And from here, I can also see that this portion v square upon r is playing a part of acceleration, because if I carefully see, f net was equal to what? M times acceleration. And then in this case, acceleration part will be v, acceleration part is equal to v square upon r. That's what it is. And this is the centripetal acceleration, so I'll place it at AC in this case, so that you can see that this is circular force we are talking about down here. So these were some of the basics. Now, based on these basics, I'll try and take a couple of math problems. So one of the math problems which I wanted to take is down here. So it is find the magnitude of the centripetal force exerted by the rim of the dragster wheel, which is 45 kg tire, and the tire has a 0.480 meter radius and rotating at a speed of 30 meters per second. So if the mass is equal to 45 kg and has a radius is equal to 0.480, that is the radius, and the rotating speed of the wheel is given to me, v value, which is 30 meters per second. I wanted to find out the centripetal force. How I can find out the centripetal force? That will be Fc, which is equal to mv square upon r, and that is equal to 45 times v value is 30, so 30 square divided by 0.480. So after doing the calculation, let me open up my calculator, and if I were to do the calculations, so it will come out to be 45 times 900 divided by 0.480, that is 84,375, that is newtons. The unit will be Newton, Fc, centripetal force. Now we wanted to identify the direction of the centripetal force. So the direction of centripetal force will always be towards center. So Fc net, which is a net circular force, it always acts towards the center. Fc will always acts towards the center. Okay. And same thing with the acceleration also. If you are only asked to find the acceleration only acts towards the center in a circular motion, so it will be towards the center. So that was the basics about the circular motion. Now with this, I will try and take another concept of the circular motion. So let's talk about if there is an object, which, let's say there is a car. So the car which is taking a circular turn. So this is the car down here, which is trying to move in a circular direction, and we wanted to identify what is the net force on this one, means what is the value of Fc on this one. Now this car, because it is moving in a circular direction, so it keeps on changing its direction all the time. To stay on its circular path, what are the different forces which should act onto this one, on this car? So I will try and ask you guys to try and visualize that. If let's say it's an icy day, it's a snowy day where there's a lot of snow on the road, and what's the difference when you are trying to take a circular turn? In case if the car is trying to take a circular turn on a icy road, you'll find that the car will tend to slip. So it will try to move away from its position, so like this, it will try to skid away from that happens because of the inertia. Because now what's inertia? Inertia in simple terms is because of its mass, which is in motion. So because of its mass, it will try to move away. So in this direction, it will try to move away from its path, which is a circular path. Now what keeps intact is the friction. So now imagine that you are driving the car on a plain road on a summer day. So what's going to happen? So there will be a proper friction. There will be a proper grip between the tires and the roads. So that will keep the car grounded and keep the car moving in a circular direction. So what is the force which is keeping in the car moving in the circular direction? That is Fg. So Fg is equal to Fc in this case. That whatever Fg force is, that's keeping the car moving in the circular direction. So Fc is equal to Fg when a car is taking a circular turn. Now, just to give you another way of thinking, sometimes student like don't understand this completely. When I was a student, it also was a little confusing how to write down the equation if you don't know the equation. So what I used to think about it, again, this is just an analogy which I used to do, and it worked for me. But just want to tell you that this is just an analogy. Uh, Now, let's imagine I wanted to find that how this car stays balanced. That's how I when I was a student, I wanted to look into to make sure that at every moment why this car stays on its path. So why it is in its balanced position. So I in my head used to think, okay, let's say FC is acting in this direction. FC is trying to pull it away, and which force is trying to keep it intact towards the center? That is Fg, gravitational force. As long as Fc is equal to Fg, or Fc is greater than Fg, as long as that's happening, then the car will stay on its path. If uh, or shall I say, no, Fg is greater than Fc. As long as this is happening, the car will stay on its path. As I mean, if the Fg value reduces, then Fc, if this value is greater than Fg, then the car will skid away. That's how I used to think about it. But again, in reality, when we are talking about the Fc, it doesn't act away from the circular motion, not like this. In reality, it always acts towards the center. But just to understand the, just to write down the equation so that I can compare the cases, I used to imagine in my head that FC is acting in this direction, FG is acting downward, and then if the car is moving fast, now you can imagine car is moving fast, then FC is equal to mv square upon r. So moving fast means is more, so FC value is more. So if you are moving fast, FC is more. Once you surpass the FG value, your car will start skidding. Isn't that what happens when you are driving your car? So if you're trying to take a circular turn and you're driving very fast, car will try and skid away. So hopefully that helps you to understand the concept. Another place you can apply this concept also in case of roller coaster. So in case of roller coaster, which is a vertical motion, this was more of a horizontal motion when I took the example of a car. And so in case of a roller coaster, this is where the car will be. This is where the car will be, and then this location. These are the two locations where we will try and study eh, the cases. So Fg down here, Fg is acting in the downward direction. And what are the different forces acting at this position? There is a normal force, because remember, if the object is placed on the ground, Fg is acting in the downward direction, there is always a normal force. So normal force is acting in the upward direction. Upward we consider as positive, downward we consider as negative. I wanted to write down the final equation. Fc value will be equal to Fg plus Fn, and Fg is a negative force, so this is the equation I will write, that is equal to Fn minus Fg. So that's the equation I come across. And then the second case is that we also wanted to identify, how does this roller coaster stays on its path, why doesn't it fall off when it reaches on top. So again, I'm going to apply the same concept which I applied in case of car, whether the car will skid or not. So this FC, I will call it as, again, one, mark my words, FC always acts towards the center. This is just for the understanding. So as long as this is, I'm going to call it as FC, which is trying to uh, push it away from its track, and Fg is acting in the downward direction. So in this case, as long as Fc is greater than, now Fc is greater than Fg, then the car will stay on its path, means car will continue moving on its path. If Fg is greater, if the gravitational force is greater than Fc, car will fall off from its track. Okay, so that's the concept I wanted to use. So I will see what are the forces acting when the object is on this location. So I will say Fc is equal to Fg plus Fn, because these are the two forces acting, but Fg is acting in the downward direction. There is no Fn in the opposite direction now. So there's no reaction force, so this is 0. So Fc should be equal to mg minimum. So minimum, that centripetal force should be equal to the gravitational force, so that the object stays on its path. So this is the equation we will come across. So hopefully you were able to understand how you can visualize these equations. But in final results, you will always say where the Fc is acting, it is acting towards the center. Okay, this is just for for so that you can understand the question, for you guys to understand. That's what I wanted to say, and I got stuck. Anyhow, coming back to some of the questions are based on this concept. Uh, so this is one of the question. So determine the speed of a 15,000 kg round car round a curve that has a radius of 40 meters, and if the coefficient of static friction between the tire and the road is zero point 0.6, now we have to find the maximum speed. So maximum speed, how can I find out? I know the formula for Fc, which is mv square upon r. So from here I can find the speed in this case. Notice it has used the word speed because it's just not talking about the direction, and it's in circle. The direction will keep on changing all the time. And then this is a 1500 kg car. So if it is a 1500 kg car, so the mass is given to me, and then the radius is also given to me. uh, and then this is what I'm looking for. Coefficient of static friction is given to me. So car is moving in a circular track. what's gonna uh, what's gonna prevent it from sliding away from its path? That is the gravitation, that is the frictional force, force of friction. I'm not sure what did the term which I used down here when I was talking about the frictional force here. uh, you know what, please pardon me, because I used the gravitational. It should have been the frictional force. That's what I was talking about here. And I accidentally keep on calling as the gravitational. Gravitational force is acting in the towards the uh, earth surface. It should be the frictional force, friction. That's what I was talking about, so please pardon me. uh, so I'll tell you again, this is the object. Frictional force is keeping it intact towards the circle. Fc is trying to move it away. Fg is f uh, f of f, frictional force. Geez, I missed. This is frictional force. I should have written it. Force of friction. Okay. Just a name difference. Otherwise, the concept, I hope you were able to understand the concept. So coming back to the question. So a frictional force, Fc is equal to force due to friction. That's what we're gonna write it. So Fc is force of is equal to force of friction, which is mv square upon r, which is equal to force of friction. Force of friction. Now we are given the coefficient of static friction. So if the coefficient of static friction is given to us, we will use mu g. This is the formula we'll go down to, and then from here we can find out the final answer. One thing I wanted to tell you in this question, although the mass is given to me, but I can always cancel out the masses from here. What I'm trying to say, even if the questions, if the mass is not given to you, you can still solve these kind of questions. Okay, so v square upon r is equal to mu g, and v value will be equal to r times mu times r times g, and square root of these terms, that's going to give you the velocity. So if I do the math on my calculator, So the mu value is 0 0.6, zero point 0.6 times r value, uh, which is equal to 40, and g value is 9.81. So 40 times 9.81 times mu values, which is equal to 0 0.6. So 0 0.6. So zero point 0.6 times 40 times 9.81, that's gonna come out to be 235. And if I square root that number, so up to square root that number, that will be equal to 15.34. So this is equal to 15.34 meters per second. That's the velocity or the speed it should move. All right. So hopefully you were able to understand this question. Again, same way you're gonna do this questions. I will encourage you to pause the video and try and do this question. Automotive car design, prototype, and test large. The circular radius is given to me 100 meter. And then the mass is given to me 1200 kg, and is tested and found that the speed is 95. So speed now is given to me 95 kilometers per hour. I have to convert it into meters per second. How can I convert? 95 multiplied by 1000 divided by 3600. Now that's gonna come down to 95. So I'll do the calculation. 95 multiplied by 5 divided by 18, that is 26.38. 26.38 meters per second. Again, let me do the calculation one more time. 95 times 5 divided by 18. Yes, correct. Now, what is the coefficient of static friction? That's what we are looking for. And then Fc equal to Fg. This case, again, I'm not sure why I keep on putting it as G. Maybe I'm solving a lot of vertical direction questions. So this is Fc equal to force of friction. That's what I should write it as. Mv square upon R equal to mu mg. We are looking for coefficient of static friction. And then I can cancel out the masses, and from here I can find the value. V value is 26.38 square divided by a 100-meter radius, 100, and this will be multiplied by 9.81 equal to mu value. That's how you're going to get the mu value. Now, one thing, a lot of students make a mistake when when they file these values in a calculator, they don't put the bracket here. So make sure you're putting the bracket here, otherwise your answer will be wrong. So 26.38 times 26.38 divided by 100, this number again divided by 9.81, that comes out to be coefficient of friction is 0.709. That's the coefficient of you're gonna get for this question. So hopefully you were able to understand how does the force of friction works in case of circular motion. And now this is a case of the roller coaster. So a car which is trying to move in a circular direction. So this is a car which is trying to move in a geez, this is a roller coaster. In this roller coaster, so this is a bogie or a trolley of the roller coaster, which is trying to move in a circular direction, and uh, and this is in the vertical direction. So you know your imagination should be in the vertical. Earlier it was on the horizontal direction where the force of friction played a role. In this case, gravitational force will play a role. So again, I'll use the concept. Trying to pull it in this direction. If you haven't watched the video lecture from the beginning, I would encourage you to watch it from the beginning, because I placed the FC in this direction, and I've told the reason why I'm placing the FC down here also. So please don't watch it from in between, otherwise you will miss on some of the concepts. And then FC is trying to pull it in this direction, FG is trying to pull it in the downward direction. So once these two forces will be balanced, only then this car or shall I say this trolley will stay on its track. So FC should be equal to FG in this case, and there is no normal force. So FC again, which is mv square upon r, and FG is mg. I can cancel out the masses, and uh, what shall I do? The minimum speed with which it should move, v value will be r times g square root of this, and we are given that it is having a radius of 50 multiplied by 9.81. And then let's figure out the answer to our question. So square root of 50 times 9.81, which is 22.14. So V value is 22.14 meters per second. I just want to tell you all these questions are taken from the Pearson physics book. So if you want to know which book I am following, that is the Pearson physics books. That's the one which I am following. So hopefully you were able to understand these questions. Now, before I finish this lecture, I wanted to tell you about one more concept of the circular motion. Let's say if you are trying to rotate a bucket in a circular direction, this bucket is filled with water. Okay. And what are the different forces acting onto it? That's the case we wanted to see. Again, these are the two cases which we'll try and study when the bucket is on top here, on top or on bottom. So I will see, and again, this is a vertical direction motion. So what are the forces acting? This is connected with the rope. So there will be Ft tension in the rope, Fg which is acting in the downward direction here, and then centripetal force which always acts towards the center. So Fc equal to Ft, which will be a positive, but Fg will be a negative force in this case. So that's how I'm going to write the equation when the object is at location 1. And then at location 2, the forces which are acting, tension force still down, Ft is down, Fg always acts in the downward direction, Fg. So the equation will be Fc will be equal to Ft, which is down, negative, minus Fg. Now this is where sometimes you can ask the question that why I haven't shown this one as downwards. I can show it downwards here also, but this is what we are trying to find out. Whatever we are trying to find out, that is just a net effect. So if I see it clearly, if these two are negative, -5, -10, it will all final answer will always be negative. Okay, so automatically this force will be negative, and which I can confirm it with whatever we said initially, that Fc always acts towards the center. So this Fc value will be towards the center. And in case 1, you will always find out that it will come out to be, it will Fc will come out to be positive, because again, as I said, x towards the center, so it should be upwards in this case. Right, so hopefully you were able to understand the concepts of centripetal force, and then I will see you with another video lecture on this. Till then, goodbye.